My name is Charlie Nunn. I'm at Duke University in the Department of Evolutionary Anthropology and Duke Global Health. I also run the Triangle Center for Evolutionary Medicine, and it's great to see so many people here at our Club Ev Med. This is Club Ev Med discussions or conversations, actually, I think we call it the Club Ev Med conversations. We'll start with a brief talk, about a 30-minute talk today with three people presenting. And we want to hear your feedback. We want to hear your thoughts about the topic, your questions, and we'll open it up for questions at the end, but I want to encourage people to use the chat along the way. This is our first Club Ev Med of the season, of this semester. We've got about 5 or 6 lined up for this semester, and we're already lining up a bunch of them for 2026. So stay tuned for that. We're going to update the website today or tomorrow to get all those on there. Now, I should mention that Club Ev Med is organized. If I can get this to go into the, oh, it's too long to go in the chat. That's the problem. Okay, just a second. Okay, Club Ev Med is organized by a bunch of different evolutionary medicine centers. There are 10 or 11 of them. They're listed here, and also the International Society for Evolution Medicine and Public Health. I'll put that in the chat as well. That's ICEMP. Most of you know that. And I also want to encourage people to submit articles to the Journal of the Society of Evolution Medicine and Public Health. And you can find a link right there. Okay, so as I said, we're going to have a talk of about 30 minutes length, and I'm going to turn things over to my TriSem colleague, Freddy from ECU, East Carolina University, to do the introductions. Go ahead, Freddy.
Hello, thank you for having me, and thank you for the introduction. So I'm Freddy, East Carolina University, and I have the immense pleasure and honor to introduce our speakers for today, who are Estelle Raouzon. Estelle is a researcher from the University of Antananarivo, where she obtained her master's degree in zoology and animal biology. Her work focuses on threats to Madagascar's biodiversity, such as from invasive species and disease, with extensive field experiences studying birds, amphibians, and reptiles across Madagascar's diverse ecosystem. Estelle has helped eliminate an invasive species of crows in Madagascar, track the spread of the invasive cane toad, analyzed malaria following cyclones in eastern Madagascar, and is now leading a project on frog pathogens funded by the British Ecological Society. Estelle is particularly interested in how environmental gradients influence species distribution and pathogen dynamics. Our second speaker for today is Dr. Benjamin Rice, who is an evolutionary ecologist whose research centers on the ecology of infectious disease, especially malaria. His work combines field ecology, epidemiology, phylogenetics, and modeling to explore how environmental change shapes the evolution and distribution of pathogens in wildlife and human population. He is currently an associate research scholar in the Department of Ecology and Evolutionary Biology at Princeton University. And last but not least, Dr. Jessica Metcalf is a professor of ecology, evolutionary biology, and public affairs at Princeton University. Her research bridges demography, epidemiology, and evolutionary ecology, focusing on how infectious disease spread and persist across time and population. She integrates mathematical modeling with empirical data to inform public health and vaccination policy, with work spanning disease such as measles, rubella, and COVID-19. And we're really excited for their talk today, which is titled Extreme Weather and Malaria Control, Minimizing the Impact of Disruptions. So please welcome our speakers.
Thank you, Freddy, for the kind introduction. An honor to be introduced by Freddy, and thank you to the organizers. Hopefully that screen is showing up and everybody can hear me. And I'll just kick off. This is just a quick graphic as an intro of Tropical Cyclone Freddy, which hit Madagascar in 2023, and we'll talk about further. As Freddy mentioned, we'll be talking about extreme weather and malaria control, and potentially ways to minimize the impact of those disruptions on malaria control that extreme weather results in. I'm presenting on behalf of a large team, and we'll hear from some of that team. And again, it's a privilege to be talking to this audience. I think from what I could see from the people joining the audience, several people are familiar with Madagascar, so I'll spare some of the context there, but feel free to throw things in the chat if some questions come up. Just starting with the broad question that motivates our research, malaria is a major contributor to global health burden. And a question that many people have asked is how global climate change will modify malaria, particularly the ecology and evolution of those plasmodium parasites that cause malaria infections. Just more particularly, I've sort of been thinking about where will this impact be largest? And on the sort of intervention side, what are our best tools for mitigating those incoming impacts or disruptions to malaria control that we expect from the effects of global climate change? This sort of question is motivated by two concurrent global challenges. One is that sort of irrespective of climate, there's this background stall or alarming increase in malaria that we've seen in the last couple of decades, despite some well publicized and hard-fought wins in controlling malaria around the year 2000. And just Madagascar is representative of many malaria endemic countries where there's been an increase or lack of progress or even an increase in malaria incidence for the last 15 or so years. And this data that I grabbed from the WHO shows this on the right here, where you can see incidence after about 2007 has been sort of consistently trending upward. COVID certainly didn't help, but you can see that trend upward was in play well before the COVID started in 2020. And that's co-occurring with global climate change. And malaria, like many infectious diseases, and this is probably well known by this audience here, is sensitive to environmental parameters, including temperature. This has received some study from Aaron Mordecai and other research groups where they've documented that sort of the transmission suitability or transmission potential of malaria is dependent on temperature. And if you're to the left or below the peak temperature, an increase in temperature will result in an increase in the expected malaria transmission for an area. And there are certain ranges within this temperature thermal performance curve where we expect transmission to be highly sensitive to temperature, where global warming would result in an increase in the potential for malaria transmission in a landscape. And some work by Mercedes Pascual and others has observed this in the highlands of Ethiopia and Colombia, for example. And that leads to this sort of concern about malaria moving upward both altitudinally and moving sort of poleward longitudinally, and you get this expansion of malaria into areas where it wasn't as common before. But this sort of misses one aspect of this, one portion of this curve, and that's areas near the core already at the sort of peak temperature, the optimum temperature for malaria transmission, which I'm calling sort of like the core high burden areas of malaria transmission. You could think of lowland tropical Africa, for example. That curve sort of, as you can see with these red lines I've drawn, sort of flat lines and sort of increase in temperature for a couple degrees Celsius doesn't change transmission suitability much there. And so sort of what I'll argue today is that these core high burden areas that contribute the vast majority of malaria cases, there may be some factor other than temperature. That's the major consequence of global climate change on malaria transmission. And just to illustrate that, we can look at the sort of expected number of cases in a given year in different regions of the world. And just using Madagascar as one African country, you can see that Madagascar alone here on the right, which is pretty small, hopefully you can see this, but just Madagascar alone with over 5 million cases of malaria per year contributes more malaria cases than all of the Americas combined, and sort of on par with all of Southeast Asia. And that's just one of several dozen high burden African countries. And sort of the takeaway from that is that in these core areas where the vast majority of malaria cases occur, maybe something other than temperature, and maybe it's something like extreme weather events may have a larger effect on malaria. And this is also motivated by data showing from the climate literature that extreme weather events such as tropical cyclones, hurricanes, typhoons are being affected by increases in temperature and aerosols. And just for the Indian Ocean basin in particular, where we'll focus today, there's a series of studies that have documented an increase in rapid intensification of tropical cyclones, where they go from low intensity to high intensity overnight. There's also been a movement in the location where those storms are reaching maximum intensity. They're moving sort of poleward and coastward, so further south and further west in the case of the Indian Ocean, which means they're reaching maximum intensity closer to coastal populations, vulnerable coastal populations. And finally, some studies from the World Weather Attribution Group has shown that you can attribute excess rainfall from these storm events to the presence of excess greenhouse gas and aerosols due to human activity. And those studies I'm listing there that I pulled this from. And so just with that broad context of increasing malaria, increasing severity of tropical weather, and the presence of these massive storms in 2022 and 2023, we wanted to talk a little bit about the impact those tropical cyclones have on communities in Madagascar, in particular their health. And I'll turn it over to Estelle for this. Take it away, Estelle.
Thank you, Ben. This map shows the tracks of tropical cyclones affecting Africa over the past 4 decades, from 1985 to 2025. We can clearly see that the majority of cyclones
Excuse
occur
me, are
in-
you sharing your screen? Because all I'm seeing is a bunch of people.
Sorry.
I see the screen.
We see the screen, Joe.
Okay, and then I guess there's something wrong with me.
I think maybe if you
I'll
click
figure
on
it out.
meeting at the top of your
Okay,
Zoom.
all right.
Go ahead, Estelle.
So we can clearly see that the majority of cyclones occur in the Southwest Indian Ocean, affecting Madagascar and the neighbor coastal regions. So the data shows that almost half of all cyclones in Africa hit Southeast Africa, with Madagascar and Mozambique being the most exposed countries. In February 2022 and February 2023, cyclones impacted Madagascar, which had severe impact on communities in our study area in the Manazari district. And these photos show the devastating impact of those cyclones in our study area. Many homes were completely destroyed, leaving communities exposed and vulnerable. You can see how strong winds and flooding damage local infrastructure, such as health facilities. So this is a clear example of how the frequency and intensity of cyclones are becoming a serious threat to people in coastal Madagascar, affecting not only the housing, but also health, particularly malaria transmission and the landscapes.
Thank you, Estelle. I'll turn to talking sort of conceptually about how we expect tropical cyclones or extreme weather disruptions to alter or make malaria control more difficult. In a sort of context this this audience may be aware of is that most countries in the world don't let malaria transmission go uninhibited. They enact prevention and treatment measures to limit the exposure of vulnerable populations, vulnerable hosts and vectors carrying the parasites. And here I'm showing this as sort of like a layer of protection, minimizing contact between infected mosquito vectors and susceptible hosts using tools such as bed nets or chemoprophylaxis, insecticide spraying inside houses, and other tools. But a key point is that in the presence of malaria prevention, you can minimize the risk or the probability of infection, but that requires the regular re-administration of malaria control commodities or tools such as bed nets, prophylaxis, and other measures. And if there's a disruption, for example, due to an extreme weather event that destroys stockpiles, health facilities, transportation, and housing, you no longer are able to re-administer regularly those malaria prevention tools, and that protection will decay as sort of the half-life of the prevention tool being used is not long, and over time, if you're not reapplying those, protection decays until you get to a point where there's minimal protection existing, and at that time point, infection is expected to rebound. And we do see it after the cyclones, there's destroyed health facilities, halted or delayed distribution of bed nets, tests, and drugs. And you get a damage to housing, which can result in a decreased use of bed nets. And some of those photos that Estelle showed when she was discussing, you could see that houses are just not intact anymore, which makes it difficult to use bed nets. That's just one example of how disruptions after cyclones can decrease the sort of coverage or continuity of malaria control options. And just a sort of obvious hypothesis that results is that there may be a high risk of malaria infection in the aftermath of these extreme weather events. The first thing we did is we pulled all cyclone data from this NOAA IB Tracks database and then just some coarse estimates of malaria incidents globally, just to show where sort of malaria incidents and cyclone activity overlap. And hopefully your eye has already been drawn to the Southeast Africa or Southwest Indian Ocean, where you can see a lot of these blue lines representing the track of a cyclone since 1980, hitting a land surface colored in a bright color, indicating a high malaria incidence. There's also a lot of cyclone activity in Southeast Asia, for example, but those countries have made a lot of progress reducing malaria. So that just sort of draws us immediately to Madagascar as a place where malaria incidents and cyclone activity co-occur, and potentially a suitable place to begin these investigations. Here I'm just showing very similar data in a different format. On the x-axis, we have the number of tropical cyclones since 1980, just using the equivalent of a Category 1 hurricane as a cutoff there, and it's a log scale. And then on the y-axis, we have an estimate of malaria incidence, and then the country's dot size indicates the number of malaria cases expected per year from the WHO. And you can just see in this top right corner, Madagascar pops out as a place where there's a large number of cyclones and a lot of malaria cases each year. Madagascar is not alone. Mozambique, Solomon Islands, Papua New Guinea, Malawi, Tanzania are other countries sort of in these like higher risk quadrants. And again, we're not saying, or just an important point to make is that we're not looking for sort of a correlation here. We're not saying that cyclones cause malaria, but rather areas with a high burden of malaria that are impacted by cyclones may be subject to these sort of disruptions that minimize the ability to make progress in reducing malaria in those countries. Our methods where we had a mobile malaria clinic and we went out and sampled in a random sample of communities on the east coast of Madagascar in the Mananzari district, testing for malaria. And we did this at regular intervals before and after the cyclones. We started this study not knowing the cyclones were coming. And from that, we're able to sort of probe what happened after the storms occurred. We're working in, for those familiar with Madagascar, we're in the Mananzari district in the southeast, and we had 10 study communities up along the coast, 5 north, 5 south of the district capital, the town of Mananzari, which may be hard to see on your screen in this elevation profile. You could just see all of these places are at very low elevation close to the coast, and they all got slammed by these storms that hit sort of directly in this district. When we used a prospective cohort study from 2021 to 2023, and I'm just going to sort of use these silhouettes of human hosts that become colored when they're infected to show our general sort of study design and the data we're using for the points we're going to make later. In our study, we screen everybody for malaria using rapid diagnostic tests. The individuals that are positive immediately receive treatment from our mobile clinic team to clear those infections. And then the number of hosts that become infected in the time interval until the next sample is then indicative of the new infections that were acquired over that time interval, which gives us insight into the rate at which individuals become infected with malaria in that area. And the fact that we've cleared the previous infections gives us confidence that the infections we observe at the next time point are likely new infections. For those that don't work with malaria, this is important because untreated malaria infections can last months or up to a year, in which case individuals will just repeatedly test positive if they weren't cleared of parasites via treatment. And the sort of rate at which individuals accumulate new infections can be sort of like summarized with this parameter, the force of infection, which is just a proxy for the sort of intensity of transmission. That's the sort of key outcome that we're of interest, is trying to estimate the force of infection following tropical cyclone events. The results sort of will look like this. I'm going to show a heat map. On the x-axis, we have the number of days since the cyclone made landfall in southeast Madagascar. And here I'm showing the 2023 cyclone Freddy, for example. And then each of these columns, there's 4 panels here. I'm showing a subset of the data. You can look at the paper for the full set of data, are different localities or villages, and I'm ranking them from lower infection localities to higher infection localities, and the y-axis is age. It's a little bit of a complicated plot, but basically we're going to look for places where the probability of acquiring a new malaria infection is high. And what you'll see is that in sort of 2 months after the storm, for these high-risk age groups, school-age children, 6 to 15-ish years old, you get up to 0.6 probability of having a new malaria infection within 2 months after the storms. And I can go into more detail about these methods and how we derive these sort of estimates. But the key takeaway is that at many of these localities in Southeast Madagascar, you're getting half or so of your kids infected with malaria in a month to 2 months following a cyclone event, which is a high number. For reference, in the same area we worked in 2017, and you'd see about like 3, 10, 15% of the kids infected. Not a perfect comparison, and we're not trying to attribute a fraction of these infections to the cyclone versus a counterfactual of what would have happened without the cyclone, but just that we observed in the 2 months following a storm, more than half the kids at many of these localities are infected with malaria, which is an alarming statistic. But sort of thinking about mitigation, we have this scenario where you have the typical prevention methods like prophylaxis and treatment that decay relatively rapidly. But what would happen if we had a different control tool that lasted much longer? And for malaria, excitingly, there's these recently available vaccines, anti-malaria vaccines, and the duration of protection we expect from the vaccine is much longer than you can get from a prophylactic drug that has a half-life that decays within a couple of days or a couple of weeks. And so we just wanted to explore what would have the dynamics, what would they have been if malaria vaccination had been in place in these areas prior to the storm coming. And so we didn't go out and vaccinate. We're doing a sort of prospective exploration of what would happen if you added vaccination to the control toolkit in these areas, especially motivated by the fact that these storms are occurring frequently and more severely in this area. And the way that I'm going to show this data is that, again, on the x-axis, similar to what I showed previously, we have the number of days since the cyclone made landfall. And then here on the y-axis, it's the probability of a symptomatic malaria infection. I'm just using young children for reference. We could do this for all age groups, and we show that in the paper. And I'm just showing for a range, a low malaria infection locality, a high malaria infection locality, and we can come up with estimates for the proportion or the probability of infection at a given day for various scenarios. And this red dashed line shows how many infections or the probability of infection we expect in the absence of vaccination. And then the gray and the blue show what we would expect if vaccination had been in place. And you could see for this R21 vaccine, the sort of best currently available malaria vaccine, you're getting a much slower accumulation of infections if vaccination is present, right? That makes sense. But the sort of gap between what you would expect in the absence of vaccination and what you would expect in the presence of vaccination gives you the potential benefit to adding vaccination, to investing in vaccination in these areas. And I would argue that while these vaccines are not perfect, they're not eliminating malaria, that having or substantially reducing the number of kids with malaria and all the chaos after a storm is probably a significant or a substantial benefit. It's important to note that these vaccines are not perfect. They're not the measles vaccines that can interrupt transmission and achieve herd immunity. For those that don't work in malaria, the malaria vaccines are mostly effective at reducing the probability of severe disease rather than preventing infection, which does simplify the modeling, but does sort of, these are sort of cautious or conservative estimates to the benefit of vaccination. In the future, if we have better vaccines, again, that benefit would expand. And so we're sort of exploring vaccination here, and no vaccine campaign would be expected to be perfect. And as I mentioned, the malaria vaccines themselves are not perfect vaccines. They have a lot of sort of substantial limitations. And here we're just going to explore what would happen if you vaccinated a certain percentage of children before the cyclone it made impact, and what would be the reduction in malaria cases that you would achieve. And there's certain scenarios where the vaccination coverage or efficacy would be insufficient to reach a target. Here, for example, just for illustration, I'm going to say our target is reducing malaria cases by 50%. And then there'll be scenarios where you have sufficient coverage and efficacy to achieve that target. And encouragingly, we can see from this data that there are scenarios where, for example, if you get to 70 plus 73% coverage with the R21 vaccine, which is a reasonable vaccine coverage to achieve in places like Madagascar, you can cut in half the number of malaria cases you expect in storm aftermath. We say that 70% vaccine coverage is a realistic target, given that the measles vaccine and other vaccines that are routinely provided in Madagascar get more than 70% coverage per the literature. And again, just saying that 70%, you wouldn't even need perfect coverage and you wouldn't need a perfect vaccine to achieve this large reduction in malaria if vaccination was in place prior to the cyclones hitting. I'm going to add one more point and then I'll wrap up and save some time for discussion. I think the other thing is that this would probably have to be done in places that are known to be exposed to vaccines, such as to cyclones, places that are known to be exposed to cyclones, such as the east coast of Madagascar. It would be difficult in the week or so lead time you have when a cyclone forms way out in the Indian Ocean and you know it's heading towards Madagascar. You couldn't mobilize a vaccine campaign, and the acquisition of immunity even after the shot takes time. So you'd probably have to invest in routine, but adding malaria vaccination to the routine vaccination program proactively in areas that you think will be exposed to extreme weather in coming years, rather than sort of like a reactive emergency campaign in a couple days lead time you have before that sort of existing storm is projected to make landfall. And just to wrap up, I think our data show that extreme weather events such as tropical cyclones occur frequently in malaria endemic settings. Madagascar and Southeast Africa, Mozambique, and nearby countries are a suitable location or a high priority location for studying this aspect of climate health and the potential for interventions such as vaccination. And that the risk of disrupting health programs that extreme weather events pose make investments in continuity and longer duration intervention tools key. And vaccination is an example of that, newly available for malaria, that may buffer or mitigate some of these disruptions to control programs we expect from extreme weather. That's the end of the malaria and tropical cyclones. I just wanted to plug really quickly some future directions for our work, which is highly collaborative and in part motivated by the notion that the parasites that infect humans, the Plasmodium genus of parasites that cause malaria in humans, don't only infect humans, they infect a wide diversity of non-human wildlife, including in non-human hosts, including in Madagascar. And with Freddy, Estelle, and others, we're excited to be looking at some of those parasite ecology and Madagascar's amazing hosts. I'm picturing some of the people working on this team here, and including lemurs, where those of you who work in Madagascar will know this, but there's an extraordinary diversity of lemur species that often live in multi-species communities, are known to be infected with parasites, and Freddy and others are leading the charge on understanding how Plasmodium infection, malaria infection is affecting lemur host health and dynamics. We can also look at the parasites of reptiles. Madagascar, again, is home to an amazing diversity, an amazing radiation of chameleons with over 80 described species. Here I'm just showing their range from IUCN. These aren't super accurate, but just to get the point across that there's a lot of species in Madagascar. They often overlap in symmetry, and you get these interesting, complex, multi-species communities infected by malaria parasites, and they might be a suitable system for just understanding malaria ecology in general, which we can apply to human health, and also questions such as how cyclones affect parasites and non-human hosts, where those non-human hosts aren't sort of confounded by all the oddities of human health systems and programming and funding. And just picturing, because I really am passionate about chameleons and like to show a picture of a chameleon in every talk I give, but just showing some of the species of chameleons that coexist in northern Madagascar here. And just want to acknowledge the field team in Madagascar that made this work possible, the Princeton Climate Disease Group, and Freddy, who's been a great collaborator all along through this work. And with that, I think I'll stop the share and we can open it up to discussion. I tried to save some time for discussion. And again, thank you for the opportunity to present.
Okay, thank you, Benny. Thank you, Estelle. That was fantastic. Wow, look at all the the clapping going on. That's fantastic. It would have been perfect if you had had a leaf-tailed gecko at the end, but okay, we'll stick with chameleons.
The leaf-tailed geckos would be so interesting because they're just super abundant, but I'm afraid to sample them because their tails just falls off, and then it's like but that's yeah. We'll talk about how to sample those.
They're kind of hard to find too, at
Yeah.
least for me. But anyhow, that was fantastic. There are a bunch of questions in the chat. I see more coming in. In fact, we already have somebody with a hand raised. Jonathan Parr, TRISEM colleague from UNC. Jonathan, you want to ask your question? And please raise your hand, everyone else, for questions.
Sure. Benny and team, thanks for an interesting talk. I really enjoyed it. There's a lot to think about there. One question and a comment. Actually, I'll start with a comment first, which is to say that I do think this topic is really important and also an area where there's opportunity for innovation. And at UNC, where I work, one of my colleagues, Ross Boyce, is doing some interesting work in this space in Uganda, specifically looking at what happens after flooding events and also what can be done to kind of reduce impact. And that's one thing I like about what you presented is that you're looking at these big picture problems, a specific infectious disease, and also taking the next logical step to think about what could be done about it. So thank you for that. My question is about interventions. So you modeled the impact of vaccines. What about other effective interventions that might be, in some cases, simpler to implement or could be done in parallel? Bed net distributions, or in Ross's case, they're doing a randomized, cluster randomized trial of mass drug administration in different communities in Uganda right now. So what about other interventions that could complement?
Definitely. Yeah, I think like malaria, fortunately, there's a whole toolkit of interventions in addition to vaccination that could be applied. One thing we thought about is the sort of like reactive emergency deployment of bed nets. And one of the co-authors, Jill Lewinsky, who may be in the audience, has worked on that in other emergency humanitarian settings. I think they like dropped bed nets out from airplanes in Sudan and things like that, and sort of like non-infrastructure dependent deployment of other prevention methods could be, I think, a key measure. I think you could also, people sort of like shelter in certain places, and you could reinforce prevention in those places where people are sheltering using traditional methods like bed nets. I think another thing we thought about is if you could have like lock boxes or strong boxes or safe shelters that would guarantee that your meds wouldn't wash away. You could have your seasonal malaria chemoprophylaxis secured. In the current setting or the sort of current infrastructural context in Southeast Madagascar, just all transportation halts for so long after these storms wash out all the waterways and all the roads that a lot of the commodities require moving tons of goods at specific time intervals. And I think vaccination gets you out of that challenge uniquely. But I think in other contexts or with new technology or better proactive planning, you could have this sort of like infrastructure independent distribution. And sort of the doing that proactively would be key. And I think some of those are probably going to be cheaper and more effective than vaccination if done properly. So it's a very good question. And I think vaccination is an example of using sort of like a different intervention framing, but it's not that we're married to vaccination as the only possible tool to do this. And in fact, the malaria vaccines, as you're probably well aware, have a lot of limitations, a lot of complexity that I sort of skated over. They require multiple doses. They're only really known to be effective in a small age range, young children, and they wouldn't get you to sort of like community-wide control of malaria, which is the ultimate goal.
I mean, also, isn't there some risk that if there's a big rollout of vaccines, that maybe some of those other strategies would decay or either individually or public health authorities? And if I'm understanding correctly, the vaccine doesn't actually stop transmission, it just stops disease. And so, if you had the rollout of vaccines, but then the decay of other strategies, could it end up in a worse situation? I mean, do we have to, it seems like they really have to be implemented together, if I'm understanding correctly.
Yeah, definitely. I think there's a finite amount of resources, especially in countries like Madagascar. And if that's poorly prioritized towards one tool, it could come on the cost of others. The optimistic take in some countries have piloted this is you could integrate malaria vaccination into your measles vaccination, your routine vaccination programs, which are already in place, which would very much lower the sort of like logistical cost of doing that. I think there's some challenges associated with that. The schedules aren't exactly aligning, and there would just be the cost of buying the vaccine. The pessimistic take is sort of that the other tools that are supposed to interrupt transmission clearly aren't interrupting transmission. In Madagascar and most African countries, malaria is going up. And so maybe vaccination is sort of like a harm reduction tool that in the meantime, until we figure out the ultimate solution here, we could prevent a lot of severe illness among young children with something like vaccination, but it won't get us to the end line, which is reducing transmission to the point that the incidence declines and gets stuck at 0. I don't know, Jess, if you wanted to add anything.
I think that covers it.
Yeah.
Okay, Martha, sorry I asked without raising my hand. Did you have anything else you wanted to ask about, Martha, related to human behavior?
Yeah, I guess I just was curious whether or not there's been any work in this whole area related to human perceptions of vaccination and other measures of prevention. And I know that's something they're looking at a little bit in Uganda, but I just was curious. There is that, fear that you're not, if you're vaccinated, that you're good to go and you don't need to worry as much. And I just don't know how much the human dimensions have been considered in this whole sort of.
Yeah, I think in general, my sense from being there during the cohort study, and then I defer to my colleagues to add more context to this too, is that there's like an appetite for increased aggression and malaria public health measures. And the sort of general community sense I get is that people are like what they're doing for malaria isn't working. Malaria is going up. We need more, not less. We didn't specifically ask, so I don't have data on like vaccination attitudes. And I know that post-COVID, that's a more complicated issue. My sort of sense is that I would be surprised if there was a ton of like malaria vaccine hesitancy in the area. But again, without that data, we wouldn't know for sure. And I think definitely like uptake and execution of the vaccination program would be key. Spending a lot of money in vaccines that don't go to the people that need them would be a risk. And so I think it is a major undertaking, and we don't propose it lightly. In the absence of a sort of a non-vaccine toolkit that can kind of match the profile of what is needed, maybe the only option. That doesn't mean it'll be easy, I guess, is my take.
Yeah, I guess I was curious about the sort of the more what Charlie was getting at on that idea that, if you're vaccinated, you don't have to take these other preventative measures. And sort of whether or not that has been it's not a willingness to pay, but a willingness to adopt other measures on top of vaccination.
I think there is some fatigue with like malaria. I don't have data on this, but this is just sort of like, I think there is some fatigue in that, like, in early 2000s, Gates and others make malaria a key part of the global agenda, and they start messaging in all these communities about bed nets, prophylaxis, IPT in women, and that sort of made gains, and then that sort of flatlined and then has rebounded. And you don't see the same enthusiasm around like bed nets and other measures. So I think there's a sort of general fatigue that would apply to all control measures. I think people don't use bed nets for various reasons. I would be surprised if like bed net usage would drop in the presence of vaccination. Maybe people in Uganda or Ghana or places where they're further along in malaria vaccine implementation have looked at this. Yeah, thanks for the question.
Any other thoughts from other people along these lines or new questions? Or Jess, anything you want to add?
I think it is a very interestingly data thin area, right? Figuring out how one intervention changes another. We did an analysis in New Jersey where we looked at people who had COVID seemed to be less likely to get vaccinated. You could sort of pull that out if they'd had a test. So, but I do think that a lot of these contingencies of behaviors and how you would actually measure them remain a very interesting and hard question. And also anecdotally, just talking to WHO in Madagascar, there was a perception, people used to be extraordinarily non-hesitant about vaccines. Again, this is purely anecdotal, but there was a sense described to me that because the COVID vaccine had been delivered in unusual settings, and like just through different media than what people were used to, that had changed people's attitude to vaccination a little bit. But obviously, it'd be good to get more data.
Who did it in what way? What do you mean?
The people's attitude to even the measles vaccine had been modified by, this is in discussion with one guy, so I don't want to put too much weight onto it, but the thought was that the threads of the ways in which the attitudes to vaccines had been altered.
Huh.
So, Charlie, if I could
Yeah, go ahead, Joe.
interject. One of the things that has always galled me about these conversations, particularly in the context of disease prevention in Africa, is the failure to discuss, underdevelopment as an underlying source of all of these problems. The European and now East Asian exploitation of Africa. Africa is one of the most mineral-rich continents on the planet, but yet the people are the poorest on the planet. And so until we start taking those social determinants of health seriously, okay, we're always going to be fighting a losing battle here. It's going to be one outbreak followed by another outbreak, followed by, because this is always, and this is also true in developed nations with regard to people who are socially subordinated. It's always one thing after the next, after the next. It's because of their social position. And Africa, of course, has been historically, assaulted by colonialism and imperialism for now, was it 4 centuries? So until we start doing that, a lot of this is just, it's just the same old, same old.
I
Where's what are
yeah, go ahead.
Go ahead, Benny.
Yeah, I think in general, I think like what poverty is the ultimate driver of malaria, I think is like probably difficult to argue against. I think it's not in the broad sense as well. Sometimes it's very tangible or direct. In that study region we work, a lot of the standing water that has mosquito larvae that become Anopheles mosquitoes that transmit malaria are in this Pangolin Canal, which the French colonial administration built with forced labor. This is a massive sort of like disruption to local wetlands. And it's probably like a major source of malaria vectors in the area. We didn't specifically study that, but a lot of the sort of standing water is remnants of this colonial canal system, which is just like an example of how sort of the historical events shape health to this day in those communities. I think the harm reduction sort of framing is, while we wish we had great solutions for reducing poverty in Madagascar, in the meantime, a lot of people are getting sick with malaria, and if you can reduce the probability that that child gets a severe malaria infection in the meantime, there's tools that can do that that should be deployed, is maybe how I would respond.
No, I mean, and I completely agree with you because, I of course am focused on the situation of African Americans in the United States. And those of you who don't know my next book, Why Black People Die Sooner, it comes out on October 21st. But I could take my Why Black People Die Sooner analysis and, deploy it to the entire African diaspora. And so the point that I make, until the Western world gets serious about, whether it wants to engage in ethical, moral, political economy, we're always going to be fighting this battle. And the problem, of course, right now is we're going in the opposite direction. And that is seen in a number of venues, including the all-out assault on science. So your talk, Benny, which, shows another example of the detrimental and horrible effects of climate change. In the UNC system, we can't have that conversation anymore. So Duke, you guys can do it. Princeton, you guys can do it, but we can't teach that in the UNC system because that is now illegal.
Yep. Jonathan has his hand raised. I have a question after that if there's time. Thank you, Joe. Go ahead, Jonathan.
Yeah, I just have a follow-up question that you raised, Charlie, in the chat as well. This was all focused on falciparum, and you used falciparum rapid test, or were you looking also at other species?
Yeah, we use the pan-plasmodium test. In our area, in Madagascar, there is vivax, some malaria in Ovale. In our area, it's like 98.9% or 98%. I'd have to get the exact number, falciparum. For the data I showed, I lumped all together. You do get some, this is in the weeds for the people who don't study malaria, but you get some malaria, falciparum false negatives because they have evolution in the HRP2 antigen. So they evolved away from the antigen used in the rapid diagnostic test. And so they might hit for the pan-plasmodium on the RDT. And so we assumed Plasmodium falciparum for the results I showed. We did some PCR follow-up in previous projects, and it's 98+% falciparum. That's not the case everywhere in Madagascar, though I think in our region, it's a safe assumption. It's super interesting to think about how a different Vivax has a sort of different life history, and it might have a sort of different dynamic there. And when we're thinking about wildlife and how wildlife parasites are affected by extreme weather events as like sort of a model system, those parasites are probably more similar to Vivax than they are to falciparum, one would hypothesize. So it's something we have been thinking about. Yeah, and it's a good question.
Yeah, how many RDTs did you use? I mean, it's 10 villages. How many years was it? 2 years, 3 years?
Yeah, I think we used like
2 months.
26,000. All
Oh
of them
my God.
canned and boat carried from the nearest road to the sites. Yeah.
Oh my God. That's a lot. And so if I understand correctly, then it gives you 3 readouts, just any falciparum, I'm sorry, any plasmodium, and then it gives you it has a readout for falciparum and for Vivax. And so if it came up as the pan readout came up positive, but Vivax was negative, you assumed it was falciparum because of this deletion.
Yeah, and HRP2 was at a higher density, so low parasitemia infections, you're likely to see like the HRP2 falciparum antigen hit more than the LDH. And RDTs are not perfect. We did some sensitivity analyses to account for the imperfect detection for RDTs. And again, some of these are probably underestimates because there's, you know, the parasitemia is low enough that they're not going to hit for the RDT, and those infections are probably contributing as well.
I had a question related to the frequency of cyclones on Madagascar itself. I think you had a slide, and I think that was, you know, frequency or different statistics about them increasing with climate change in general. I saw a talk at the International Primatology meetings this summer by Jorg Ganshorn, who you probably know. And he had a slide, I can send it to you. I have a photo of it. And it showed that the frequency of cyclones has not increased in Madagascar. Wind speed has not increased. I wonder if you have, I mean, it doesn't affect your story at all because obviously it's like an avenue for cyclones to hit, you know, Africa. I mean, that's really crystal clear and it doesn't affect the story that you guys have. But I'm just wondering if you have any thoughts about where, you know, Madagascar in particular, but just in general, what exactly is it that what signal is being picked up? Where is it being picked up? I don't know if you know that, but
Yeah, we looked into this a little bit and tried to like be a little bit cautious instead of like confidently stating that the number of cyclones is going up, because it depends on the ocean basin you're looking at, how you do this. And I think there's also a paucity of data. There's only good data since 1980, 80-ish when the like satellite tracking became available. And so the sample size, and if it's a purely statistical analysis, it's difficult. Some of our climate science collaborators, co-authors on this paper, have looked at sort of like more in the weeds on the climate stuff. And I think it's more like metrics like the cyclones are reaching their maximum intensity closer to coastal populations than they were before. Maybe a better metric than the average wind speed of a cyclone that hits. And there are some papers that do counter and say like you expect fewer cyclones but of higher intensity, or in some ocean basins, climate change may result in fewer cyclone hits. I think Madagascar is situated such that like a somewhat robust pattern is that cyclones in the southern hemisphere are moving further south, and a lot of them would kind of skirt over the northern part of Madagascar. Now they might be moving and hitting, making landfall. So I think there is data suggesting that cyclones are going to get worse in Madagascar. There is nuance to it as well.
yeah. Okay. Okay. Any other questions? We're almost at the end here. Any other questions? Anything else in the chat that we didn't pick up on? Actually, I think Joe had a question about the HBS allele, sickle allele. What do we know anything about that in that region of Madagascar or Madagascar as a whole? I imagine it's quite variable given what a melting pot of histories Madagascar is, but
definitely on for the Madagascar context, coastal populations have more African ancestry, sort of interior high plateau populations have more Asian ancestry, but it's a gradient and it's quite mixed. There definitely is sickle cell allele present. Duffy negativity, which is another red blood cell polymorphism, is quite common. And there's a good paper from, I think, a Penn State group don't quote me on that, but I think there is a good paper showing that there was evidence of selection in the human genome for malaria-associated polymorphisms. They used Duffy negativity instead of sickle cell as their marker from that. We do have some kids in the cohort that have sickle cell, which indicates that it's present. We didn't test for the prevalence there. I don't think it's as high as it is in mainland Africa.
Yeah, because I mean, the data I've seen suggests that thalassemias are higher in southern Africa in that region than HBS. That's why I asked the question.
Yeah, I think there is some evidence of that, like ovalocytosis. There's some literature on that in Madagascar. Yeah, interesting question.
Okay. Other question. I know a few things have just popped into the chat. I don't know. Rooney, do you want to ask your question? Anybody else have a question? She asked, is there any investigation of genetic diversity of malaria parasites after disruptive weather events and whether this affects vaccine efficacy?
Yeah, it's a good question because the current vaccines is a really good question. That would be like a great grant application. There's the current vaccines target the CSP protein, and they know that there's a lot of polymorphism in falciparum, at least at the antigen that's targeted by the vaccines. I have two immediate places I would go with that question is one, you could just get a big disruptive event leads to by random chance of fluctuation in allele frequency, in which case you would expect the allele distribution to be different after the storm because of random like genetic bottleneck type effects, especially if the storm kills a lot of adult mosquitoes by blowing them away. The other is you could imagine if you implement a vaccine in an area expecting cyclones, maybe a cyclone doesn't come anywhere every year, so you've been vaccinating for a long time with vaccines that are preferentially protective against certain alleles. You could imagine that would be a selective pressure for other alleles to rise. I think some people are studying that in mainland Africa where the vaccination programs have been in place longer. The last thing I would say is you could also use genetic diversity as just a marker of the population dynamics. And so you might expect not at the alleles under selection because of the vaccine, but just sort of standing genetic variation in the Plasmodium population. If the population is expanding after the cyclones because the cyclones result in a larger, transmission suitable environment, you would expect to see the signature of like a population expansion in the genetics. And that may be a signature that's easier to observe than like trying to pull it out of case reporting data from a health system that's not functional because the cyclone wiped out the health system. So it's a really good question.
Yeah, great question. Okay, we're going to close it up here. Thank you guys so much for a really great talk. This is fascinating. I love this paper, and you guys did a great job presenting it. Thank you, Freddy, for doing the introductions. Thank you, Jennifer, for organizing everything. I know it's a big lift. Our next Club I've Met is going to be infectious disease related again. I'm going to paste into the chat here. We're going to focus on this paper recently published in Evolution Medicine and Public Health. It's going to feature Jim Bull, Rustamantia, and Katya Cole. And it's the title is Waning Immunity Drives Respiratory Virus Evolution and Reinfection. That's October 30th. Stay tuned. Sign up for our listserv if you're not already on it. And hope to see you guys then. And we have a whole bunch of other talks coming. It'll be on the website soon. So thank you guys for tuning in. Hope to see you soon. Thanks, Jess. Thanks, Benny. Thanks, Estelle.